This is the help video for the student demo modeling Milankovitch cycles. Essentially, what you have to do here is you have to prove to me that you know what a Milankovitch cycle is and how it affects the Earth. So you're going to use a globe. You're going to show me how the Earth, using a globe, how it changes, either the eccentricity, the obliquity, or what the precession does. You have to show me that and tell me what effects that has on the climate. These are long-term changes. And so the best way to do this is to make sure you understand what the heck is going on. So I created some questions here that will help draw out what's going on with each of these cycles. So the first one I have down here is for eccentricity. Now we learned about this in unit 1.3. We did a really long gizmo that counted as a test. You should still have that in your binder because, we keep everything that we do. It's like your own personal textbook. But if you didn't keep that, I can help you here. But first, let me just explain in general what to do. Answer these questions first. And once you know all about these questions, then you really have to just think about it. Think about how that cycle would affect the Earth. I do have something to help with that. If you click here, there's a simulator. Okay. Now, what we have here, you can do a top view or a side view. You can stop the rotation, stop the orbit. There we go. That's just going really slow. And then what you can do is you can look at eccentricity. Now here's a graph over here. If you watch, I'll help you with eccentricity. See the orbit of the Earth? I can go to top view too. Now over a certain amount of years, do you see what's changing in the Earth's eccentricity? It's subtle. It's not a huge change, but something is changing. You can actually visualize it with this tool. You see it? And then you can turn eccentricity off and look at precession. You can check out what that does. And you can turn that off and check out tilt. Some of these are very subtle. If you do it fast, you can see what's happening. But use this simulation as you answer these questions. Where'd those questions go? Here it is. So the other one I'm really going to help you on is because it's been a while. This one. The formula for calculating the eccentricity of an orbit is you take the distance between the focal points. Sorry, someone keeps trying to call me. The distance between the focal points, which would be this distance, and you got to take the distance between the whole distance, the width of the whole orbit. I believe they use C and A for this, but I'll just say F and O. And so you're going to divide and then whatever answers you get, you can compare those numbers when you write them here, whatever you get, X, Y, whatever. And you can compare those numbers to what shape you see, and you can make some inferences and answer the other questions below. If you have any questions about this, remember, just reread it, take your time, check your notes. We talked about the axial tilt in your notes this unit, but also you can call me over if you have any questions.